Hello, everyone. Thank you. I'm so happy to be in this conference. I was expected to be there, but unfortunately, because of the situation in Australia, and as we know, in the conflict in the Middle East, there's a new law that might cause some problems for me for re-entering to Australia. That's why I couldn't leave Australia, and I'm presenting it virtually. And do I need to share my screen or the slides will be presented? Okay, so let's start. I'm going to talk about the progress in suture-free nerve repair that will combine two different methods. One is electrical stimulation and using bioadhesives to enhance the regeneration of peripheral nerve injuries. First, let's see what is peripheral nervous system. Everything that comes out of the brain and the spinal cord is a nerve and is part of the peripheral nervous system. It could be damaged, like by accident, by falling, blunt or sharp cut. And there are two main categories of damage to the PNS. One of them is Seddon and the other one is Sunderland. As you can see on the right-hand side, from the top is the normal nerve, which has an axon, myelin sheath, and 3 layers of connective tissue. The second one is grade 1 of the Sunderland grading system, the injury to the nerve that in the Seddon system, it's called neuropraxia, which means that just the myelin sheath is damaged. The grade 2, which means it's called axonotmesis, apart from the myelin sheath, the nerve itself, the axon is cut as well. And the neurotmesis in the Seddon categories, in the Sunderland is divided into 3 different grades, 3, 4, and 5, which means in the grade 3, just the endoneurium is damaged, grade 4, perineurium, and in grade 5, epineurium, and it means the final and complete nerve cut. And let's talk about the importance. Around 20 million people just in USA are suffering from PNI. 52% of them, they get recovered because PNS, one of the main differences between PNS and CNS is that nerves can regenerate, but the problem is that it's so slow and most of the time it's not complete and 100%. That's why 52% of them are partial functional recovered. 3% of all the hospitalized injuries are PNI in Australia, and most of them are crushed. Crush injury is more than cut injury. And 150 billion USD is financial burden in healthcare system in USA. There are some treatment methods. One of them is using bioadhesives. It can be just self-sealant or no using light or laser, or it can be compiled with laser and light. And also there's electrical stimulation as well. There are other types of treatment as well, like suturing, that we don't want to talk about them. Just these 2 main treatment methods are focused in this article. And electrical stimulation can be direct or wireless. Let's go deep into it. For example, bioadhesive. It can be self-sealant. For example, fibrin-based glues that are used in wound as well. But in the nerve system, it's new, something new, that in 2018, it's used between 2014 and 2018 in median and ulnar nerve injuries. It's used in humans, but the final results was not that much better, was not significantly better. However, it was better in the operation time, it was shorter, and the complications, like what sutures have, for example, scar tissue, it was less using glues. The other material can be chitosan based, which is our material as well. Let's make a clarification that this article is kind of review, but based on my project in Australia as a PhD student. We are using a chitosan based, but it was used before in 2016, a modified version in rats, and they compared it to the suture controls and they showed it was significantly better. It can be used with light or laser, as you can see in the picture. For example, in A, Epineurium and perineurium was sutured. And in C, you can see after using fibrin-based glues, they've reinforced it with light or laser and then sutured the perineurium. And they saw that it's reduced, that the time of the surgery reduced, and also the complications was better, and also the results was slightly better, not significantly. The other method is using electrical stimulation. For example, Warrior et al. In 2023, they have used a modified direct stimulation on the sciatic nerve of rat, and they have stimulated just once, 1 hour, 20 hertz. They didn't mention the amplitude of the voltage. And they said that direct stimulation significantly enhanced the axon elongation and regeneration compared to the untreated, not compared to the suture. What we are doing, one of the complications the Warrior and et al. Had was that they needed to leave the wound open. That was kind of problems with the desiccation, and also you need to irrigate every time, and also increase the chance of infection. But in this method that we are going to use is that we want to use a chitosan-based modified material, which will use laser instead of suture, so we don't have the complications of the suture. And also we want to close the wound, and weekly we will stimulate using a TMS, it's called transcranial magnetic stimulator, to stimulate it from 6 centimeter distance. So let's go deep into it. First, we make this graft, we call it graft, made of rose bengal and acetic acid in chitosan. The thickness is 0.015 millimeter, so thin, and a gold layer, 1 millimeter, will be applied onto it with 70 to 80 nanometer. And we will first we will crush the nerve, and then we will apply it in proximal or distal side. We want to compare these two sides to see if it does make changes. And using a green light, we will around 1 minute, we will expose it with laser to attach it to the nerve instead of using suture. And then we close the wound and muscle and skin. And weekly, we will stimulate it wirelessly for 1 hour, 1 hertz, and 0.72 Tesla. It's kind of magnetic field, electromagnetic field, but when it gets to the gold layer, it will transfer the electrical stimulation to the nerve. My supervisor has tested it before in a cut nerve, but the results in a cut nerve was better, slightly better, not significantly, and they didn't test it some other tests. What we are doing right now, for example, it was just electrophysiology, but now we are testing it behaviors and histology and electrophysiology, and also the model is different. It's crush model, which is the mostly what happens in the PNIs. And this is the setup we have. This is the TMS head coil. There are 2 coils, and they will trigger the electromagnetic stimulation. And this is the anesthesia. And these are the behaviors test. On the left-hand side, you can see the von Frey, and the middle, it's triple B, which is the beginning of the 3 scientists' name. Besso, I forgot the full names. And on the right, and let's talk about a little bit about this. For example, on the left-hand side, it's about the sensory, mechanical sensory. In the middle, it's about the motor nerves, and see how they walk. There's a score between 0 to 21. And on the right-hand side, it's Hargreaves test, which is the thermal sensory test. Unfortunately, I don't have any results right now because of one of the main reasons is that animal ethics. It took a long way in Australia to get in my university. And I'm the 3rd year PhD student, and I could start, and we have some raw data in some of the groups, but not the main groups. And we are doing in the negative control, which is just the crush nerve, and also the adhesive plus gold, which is our next step. But we are hopeful that we will get good results like it was before in the previous PhD student. And that's it. Thank you so much for your attention.